Hi, I'm Michelle Marshall, and the protein that I was assigned was lysozyme. It is part of an enzyme. I'm going to go ahead and start off with lysozyme's history. It was discovered by Alexander Fleming in 1921. How exactly that happened was Fleming, during the war, got pretty sick, more like a really bad cold type of deal, and he went to St. Mary's Hospital, and how his mucus was excreting out of him, he just decided to put it in a petri dish. And I guess he soon later forgot about it, and then next thing you know, 7 years later, he looked at the petri dish and ended up finding penicillin, which he soon led to him finding lysozymes. Lysozymes are also known as acetyltylamyl glycohydrolase. They are the first enzymes whose structures were worked out in atomic detail by X-ray crystallography. Next, we're going to talk about the natural antibiotics, what are lysozymes. Eggs, saliva, and tears, I kind of just put them on there because they are like the main things that have lysozyme, which is the white part of the egg, your saliva, and your tears. Talking about tears, a good explanation I think would be our body is covered with skin, so we have protection against things, but unfortunately our eyes don't. And so exactly what happens is if bacteria or anything gets in the eye, what lysozyme does is help process it and secrete it out, which makes our tears. Also, I put the immune system because it is an antibiotic and it does help take out bacteria from the body. And yeah. Here's also a graph that I did find. It has the different sources of lysozyme and the amount of lysozymes in these sources, which are like your tears, human milk, cow milk, your spleen, and your pancreas, and different other things. The mechanisms about lysozymes are they're enzymes that are responsible for degrading bacterial walls. Exactly how that happens is bacteria cells are under pressure due to intercellular osmotic forces. So cutting even a small part of their polysaccharide chain can rupture the bacteria really dramatically. And so that's usually how lysozymes end up destroying the bacteria. Also, lysozymes are pretty small and stable proteins, and they are isolated easily in large quantities. Hydrolysis. So what exactly hydrolysis is it's an enzyme that comes with the lysozyme. What exactly it does is it breaks down the reaction with a water molecule, but unfortunately sometimes when they break down that polysaccharide chain, the polysaccharide does survive and can live through the water. So what happens next is, actually how it happens is the activation energy is what keeps it alive. So what has to happen next is a transition state, which we're going to have to rotate our polysaccharide into a different shape and make it into a different shape for it to be able to be distorted. But sometimes that takes a really long time due to the aqueous solution being at room temperature. So the energy of the collision, it won't be able to, or it will take a really long time. So exactly what the enzymes are going to have to do is lysozyme is going to have a binding site, to have an activation site really, and from there go on and try to break down or speed up the process, I guess you can say. And that is my protein.